Hello and welcome back to the video lecture series on statistics for machine learning. So we are going through a very important topic, which is random variable and the probability distribution. So already we have seen that a random variable basically is a function which converts the outcomes of a random experiment to real values, right? So uh, that's the first thing. So if I consider a random variable x, that basically converts the uh, outcomes e to xe, which are real values, right? And those real values may be reflected as x1, x2, and like this to xn, right? Now, when I am able to, when we have this set of values of random variable as a discrete or rather finite, right? So this kind of a random variable, is known as a discrete random variable. We have already seen that. And for a discrete random variable, when we have kind of a distribution like where we have this x and the different values of x, and then px equals x, that is the probability of x equals to a specific value of x as the different values, probability values, p1, then I have p2 and all this to pn. So this kind of a distribution is known as a discrete probability distribution, right? It is often, this px is equal to x is often kind of replaced, or rather it is denoted by this function fx, which is called the probability mass function or the probability function, right? So this PMF fx is a very important thing, which kind of gives you the values of the different probabilities for the different values of the random variable. So for each value of x, it will give you the value of p, right? So that is the fx or the PMF. Now, if I just see a very trivial kind of a random variable, say when I'm throwing a die and the points represent the different values of the random variable. So 1, 2, 3, 4, 5, 6, right? And this is the value of x, and the value of fx here, the value of fx or the value of probability at x is equal to x, for each case is 1/6, right? Because every outcome has an equal probability, right? They are equally likely, so 1/6, right? So in this kind of a case, I can represent this fx by a simple value 1/6. Okay, this kind of a distribution where all the probabilities will have the same value is known as a uniform distribution, right? This is a uniform distribution where every value of fx is going to be the same, right? It's going to be uniform, right? It's a uniform distribution. Now, this is one type. Like this, I can think of some other type, right? Say, for example, I can represent this fx by some other function like fx is equal to ncx, which is basically a combination, n combination x, and then p to the power x and q to the power 1 minus, p to the power x and q to the power n minus x, right? So q to the power n minus x. I'm sorry, it's not getting written. Okay, n minus x. Sorry, this is not working. 1 second. Okay, so p to the power x and q to the power n minus x. Okay, so this kind of a distribution where the probability mass function has this kind of a pattern, right? This formula is known. This is another very important probability distribution, and this is again, this is for discrete distribution, and this is known as discrete distribution, and this is known as binomial distribution. Okay, binomial is one of the very popular and very important uh, discrete probability distribution, okay, or a probability mass function, right? So now if I just try to see a specific case where I can apply the binomial distribution, right? So, oh, one thing I missed out is here when I say P and Q, P is basically P and Q. The relation between P and Q is P plus Q is equal to 1. So, if one part P, when this P represents the probability of success, Q represents the probability of failure, right? So, and N represents the number of trials which have been conducted, right? So let's now take an example. Say if I consider the tossing of coins, okay, and let me examine. Let me just think about three coins being tossed. Okay. Now, what is the? I mean, if I want to see the probability distribution of, or rather, if I want to find out the probability of one head, the probability of zero head first, one head, two head, and three heads. So maximum I can have three heads, right? So in that case, I have to find out the probability distribution. So what is the probability distribution? Number of heads is the random variable, right? So number of heads 0, number of heads 1, number of heads 2, and number of heads 3. Okay. So these are the different values of x. And the fx is supposed to follow a binomial distribution. Okay. So if I know that it follows a binomial distribution, so when and the formula is for fx, the formula is fx is equal to ncx p to the power x, where what is the p to the power x? Probability of getting a head. So what is half, and q to the power n minus x. What is q? Basically 1 minus p, so that is also half, right? So this is the thing. Now if I consider the value of x as 1 or rather 0, so ncx, so ncx, that means 3c0, okay, and then p to the power x, so half to the power 0, and then q to the power n minus x, so half to the power n is 3 minus x is 0, so 3. This is the value for x is equal to 1. Okay, so what's going to be the value? Let's figure that out. So the value is obviously going to be 3c0 is 1, okay, 1 into half to the power 0 is again 1 into half to the power 3. So 1 by 8, right? So this probability value is going to be 1 by 8. Now the next one, for x is equal to 1 when the random variable has a value 1. So then what? 3c1 half to the power 1, okay, and then again half to the power n minus x, so 3 minus 1, that is 2. So just remember, in this particular case when we are talking about tossing of a coin, it's always going to be half to the power 3, because whatever adjustments are happening, ultimately it's going to be half to the power 3, because uh, this half to the power x into half to the power n minus x, that's going to be half to the power n always, because x plus n minus x, so x is going to cancel out, so half to the power n, so always it's going to be 1 each. So we have to just bother about this 3c1 or 3c2 or 3c3, right? So what is 3c1? 3. So 3 into 1 by 8, so that's the value, so 3 by 8. Again this one is going to be 3c2. 3c2 is nothing but again 3 by 8, so this is also going to be 3 by 8, and this is going to be 3c3, so 3c3 is again 1, so 1 by 8. So if you just try to do a double check whether this is correct or not, you can just sum it up and see whether this is equal to 1 or not. So if you just do a sum of 1 plus 3 is 4, plus 3 7, plus 1 8, 8 by 8 is 1, so this is 5, right? So like this we can use the binomial distribution as the probability mass function. So for binomial distribution, the probability mass function is going to be like this: ncx p to the power x q to the power n minus x. So this is the example that we talked about, is the example with the tossing of a coin. So for that reason, we could assume p as half, because that's a chance of a success. And here success is what? Getting a head. So getting a head, probability is 1, right? Sorry, probability is half. And q is 1 minus p, which is again half, right? This is the way we can do the probability distribution function, or even for a particular value of x, we can find out the corresponding probability using the probability mass function, right? So this is how we can use the binomial distribution. So a couple of important points you need to note about binomial distribution, and this we are going to use later on also. So first of all, for a binomial distribution, there are few standard values, like mean of a binomial distribution is equal to, mean is equal to n multiplied by p, np, right? So that is the value of mean. And the variance of a binomial distribution, the variance is equal to, I'm sorry, the variance is equal to n into p into q, right? So here for this case, like the mean is going to be n. So n means 3 into p, so half. So 3 by 2. And the variance is going to be 3 into half into half. So that's going to be 3/4, right? So standard deviation is going to be root over of NPQ. I mean, it's the root over of variance. We all know that, right? So standard deviation is equal to root over of NPQ. So these are some properties, standard properties that we have for binomial distribution. So this is all about the binomial distribution, which is a very popular discrete probability distribution. When we come back, we are going to talk about another very important probability distribution. Okay, so stay tuned. Thank you very much.